take headphones out and be ready for this lesson. It's got a couple little hiccups in it. Yeah, a couple little hiccups. So watch out. It starts by saying graphing, substitution, elimination. We've already learned 3 methods of how to solve. And graphing we sort of knew how to do from last chapter. So that was fairly repetitive. Substitution, elimination. Now, you should have 2 questions as we get ready for a test. First question is, how do I do each one of these methods? Maybe you're not very good at them yet. Maybe. And then how will I know which method to use? Well, that's what today's lesson is. That's what I'm teaching today. How do I know which method to use? So this says read all 4 problems. Look at the equations. Can you find one that could be used for each of 3 methods? What I mean by that is find one that you could use each method to use. We're going to try to practice each of these methods. Which one would be best for it? If you had to choose, which one would you choose? And then solve each problem using the appropriate method and explain what the solution means. Okay, actual word problems. Now, word problems in math often get a bad name. People are like, oh, the word problems, that's what gets me. It shouldn't be a big problem here, actually, because we give you the equations. You could read the word problem at the end if you wanted. You actually could. I'm not suggesting doing that. I'm just saying you could. Not even worry about the word problem, just look at the equations. We've been solving equations like these all the way along. Let me read each situation, though. The number of points scored in hockey is obtained by adding the goals and the assists. One year a player scores 60 points. He scores 10 more assists than goals. If we let x be the assists and y the goals, here's what the equations would be. X plus y, goals plus assists is 60, and goals minus assists is 10. That's where they get the equation from. Our job, again, to decide whether we'd like to solve that by substitution, graphing, or elimination. Next situation. A golf club charges an initial fee at the start of the year and then a greens fee for each round of golf played. Actually, most golf courses do charge like this. You got to charge to be a member. You get charged for being a member at the start of the year, and then you pay each time you go to play golf. One member played 12 rounds and paid $8.14. Another member played 29 rounds and paid $11.88. If x is the initial fee and y is the cost for each round, here's the 2 equations. Exactly shows the equations for that situation. Third situation. At a sale, CDs. Do you know what how old is this example? Does anyone buy CDs anymore? Is that still a thing? It's all streaming now, is it? All CDs are the same price and all DVDs are another price. One student buys 5 CDs and 3 DVDs, and the cost is $85. That's the first equation. 5 CDs and 3 DVDs adds up to $85. And then the other one is another student buys 3 CDs and only 1 DVD. Their cost was $39. But you're given the equation. You don't have to make the equation. And last one, 2 halls are being considered for a wedding. One charges $200 for the hall plus $10 per person. We made those equations last chapter. Those situations, we did pretty well on the test on these, making up an equation. And then the other charges $280 plus $8 per person. Now, after all that, we've got to find one that we can do for graphing. Can anyone give any input on this? Which one might be good for graphing? And we'll just discuss it. That's all we're going to do today is discuss which one might be okay for graphing. I on purpose have made it so none of them are really good for graphing. But if we had to do one for graphing, which one do you like? He's totally right. If you had to choose, if someone said, you've got to do one of these by graphing, you choose number 4. He knows something about this situation. So it's our job to figure out what it is he knows. Let me read the 2 equations, and it might give it away, just me reading it. And then we'll find out why you decided on number 4 for graphing. C equals 200 plus 10p. C equals 280 plus 8p. Why is it that one is well suited for graphing? It's all even numbers? Yes, that is another good reason for graphing, because we're not dealing with any decimals here. What else? Yes, the x and y intercept. We can see what the intercept is directly if we went to graph it. That is true, also true. What else do we like about it? Joseph? Yeah, it happens to be c equals here. That's the part I'll highlight. Everything everybody said was true. but that's C equals at the start. Is that what you were going to say? They're both C equals. If we're going to graph, we don't necessarily want to graph, but if we're going to do it with ones that are already C equals. That'll make our job a little easier. So I'm going to put beside that one. That's the one. Whoa, look at that crazy rating. That's the one we're going to graph at some point in this lesson. By the way, my lesson is just do these 4 examples. That's all I'm doing today. Okay? All right, well, before we relax, my watch wants to be involved in the lesson. Okay, well, if that's going to be the graphing one, which one's a good choice for substitution? I think you could defend any of them, but which one do you like the best for substitution, and how come? He likes 2. If I was going to choose, I think I'd agree with you. But what is it about 2 that you like? It's almost x equals, isn't it? The x's are already by themselves ready to go. So it's not going to be much work to make these both x equals. We're going to have to do this much work. It's not the greatest substitution question ever, but it's okay. So I want you to write beside that one, substitution. By the way, you might be like, well, there's 3 different methods and 4 questions. How are we going to do the 4th one? You get to choose. Question.
In problem 4, on my paper, it's backwards. Like the 10 and 8 are here.
Oh, yeah. Yeah. We'll talk about that too, okay? Someone's retyped it at some point and typed it the other way. So I'm gonna when I copy it, I'll copy it and make it look like yours. Yeah, good catch. Obviously, I think what happened is whoever first typed this up typed it this way and then realized that might not be the easiest way to understand it and then typed it that way but never fixed the flip chart here. But anyways, I'll talk about both because I wanted to talk about potential problems in all this too. All right. There's one of these 2 remaining that would be great. I mean great. It would show off how awesome elimination is because when elimination goes well, it's the best one. It goes really fast and really easy. Which one is it? Number 1. It's got elimination written all over it. It's like, hey, you're going to love this if you do elimination on this one. Stare at it for a second and see if you can figure out why he's picked that one off as a great elimination question. Positive, and it's ready to go. You don't have to do any work for that one. Okay? Here's the order I'm going to do them in, though. I'm going to go after elimination first. Then I'm going to go after substitution. So it's the opposite order that you'll see in your page there. And then we'll go after this at the end. We'll decide at the end what we like for this one. So move ahead until the elimination one. We'll skip the graphing one, we'll skip the substitution one, and we'll jump right to elimination. If you look on your sheet, there's 4 boxes. We're going to work in the bottom left box, and we've chosen for elimination, which problem number? I've already forgot what we chose. Oh, it's number 1. And the reason I'm doing that is I'm really trying to help anyone who the algebra of this is not going that great for them. They're not getting too good at it. They're struggling a little bit. Their confidence is beat a little bit. And I want to reach out and get them a little bit and go, well, okay, is there some tough questions in this chapter? Yes. Well, let's at least get the easy ones. And this one is pretty nice for elimination. What were the 2 equations? The first one was x plus y equals 60. And then x minus y equals 10. Whoa, careful now. Going crazy there. X minus y equals 10. And we talked about why this one's such a good one. And when you run into these ones for elimination, you got to smile at the situation. It's plus y and minus y. If I just add those 2 equations, just draw a line and write add, this example will show off. Even if you haven't ever seen elimination before, or I didn't understand the elimination lesson, or whatever, you got to love what happens here. What's x plus x? Remember, when it says x, it means 1x, and then we're adding another 1x. That's 2x. Then y and negative y. I don't even know what y is. But I know if I have positive y, and negative y, and I put those together, 0 y. You know, I could write 0y. It wouldn't be wrong to write 0y, but it just cancels out. It's gone. So I don't have to worry about that at all. That's why it's called elimination. Very quickly, you eliminate one of the variables. Now, it's not gone like I don't ever going to figure it out. It's just like it's gone. I don't have to work with it right now. And then 60 plus 10? That's got to make you happy. There's some complicated questions in this chapter, but that's not one of them. That's pretty nice. Because I only have one more step to get x. What's the opposite of multiplying by 2? Divide. So I go 70 divided by 2. Maybe I need my calculator. No problem. X equals 35. I added 60 and 10 to get 70? What? Number 1? Okay, we're okay? Now last step. Sub x equals 35 back into here. I'll write it in blue. Sub x equals 35. Now I know what x is. And I'm subbing it back into x plus y equals 60. And if you're having trouble with substitution, I suggest writing down the equation you're going to substitute into. Write the whole thing out. And then write it again. But don't write x anymore. Write 35, the number we figured out it was. And the opposite of adding 35? Subtract 35. And I wrote the wrong thing there. I don't know why I wrote 30 there. That's completely wrong. It's 60 minus 35. And does my 35 look like a 38 all of a sudden? My pen must have dragged there a little bit. Sorry if you copied that down, because it was not right. Y equals 25. Now, that's all the same, actually, as last week. The only thing new is, in a word problem like that, we have to answer what these things are. That is, if you reread the word problem now, you should be able to tell what these two things are. Let's go back and read problem 1 and see what x and y happen to be. Problem 1 says, x represents the number of assists and y represents the number of goals. So when answering this, so he had 35. I've already forgotten what x was. Was x the goals or the assists? X was assists. So he had 35 assists and 25 goals. Listen, I'm not saying you can't write point intersection. You can. It's just that this more relates to the question that was asked. Like we're right on top of being able to do real life math now in the real world. So yeah, you could write this. Point of intersection. 35, comma 25. That is true. That is the point of intersection. But there's a word interpretation here. So don't be intimidated by word problems. So just at the end, you got to go back and go, well, what were we talking about here? Okay. Questions there? I'm 1 for 4. What did I promise to do next? Substitution? That was elimination. You have any questions about elimination? And there are hard elimination ones, but there's some that are so easy. Okay, so substitution. We decided on number 2. X plus 12y equals 814. 814. Another good reason we don't want to graph this thing. 814, that would be weird. X plus 29y equals 1188. You can write them how you want. I like putting a little arrow here when they're not written just the way we want for substitution. How do we want the equations to look for substitution? x equals, right? Long, awkward pause there. We want these both to be x equals. That will make substitution reasonably straightforward. So I got to move those over. The positive 12y's got to move over. So I get 814 minus 12y. And the 29y's got to move over. 1188 minus 29y. And then this sentence that I stole from somebody, they're both equal each other. So here's the next big line of substitution. 814 minus 12y has to be equal to 1188 minus 29y. I just make those equal. Once they're both x equals or both y equals, I can just make them equal to each other. Does it sound like I said equal? Equal each other. Equal each other. Hey, I like this setup. Every time you guys want me out of the way, I get to sit down for a few minutes. Catch a little break. This is a little harder than elimination. A little more work here to move these over. The 814 is positive. So when I move it over to the right side, what happens to it? It changes over, yeah. So now it becomes negative 12y equals 1188 minus 29y, now minus the 814. The subtract 29y has to come this way. And when it comes this way, it becomes add 29y. This was the whole point of equation solving. Get the letters to the left and the numbers to the right. Then we need some help, either from a calculator or someone who's got this integer thing figured out. What's negative 12 yogurts plus 29 yogurts? Positive 17. How did you do it? Because there's two ways to do it. He just knows. It just pops in his head. He just knows. Yeah, that's what I was looking for. Look at, it's really just 29 minus 12. I know the symbols are all over the place, but that's all that's really going on there is 29 minus 12. And then 1188 minus 814. I don't know if anyone's doing that in their head. Are they? $11.88 minus 814. 374. Last step.
It's a lie. Okay, ready?
Folks, put the phones away. Not bad, not bad. 374 over 14, no one's doing that in their head. 374 over 17. You punch it in your calculator. 22. It's not that impressive. I've been doing the same thing for 23 years here. So, I don't know. Does that prove that I don't know. Maybe it just proves I need to get a life, maybe. That's all it really proves. I am. Okay. I didn't say your name, though, when I said put the phone away. Yeah? Just in case Mommy or Daddy watches the video. Hey, can you put your phone away? Scalba? Phone? Jeez. But that is not all. Now what do I do with the 22? Tell me. Sub it in. See, this chapter is weird. It's difficult, but it's so repetitive. Eventually, you do see all the steps. This has got to go in. Well, there's lots of places it could go. I chose right there. Do I got enough room right here? I'll draw a little line. Are you running out of room? Into x equals 814. I said 814, but wrote 18. 814. 12 times 22. 12 times 22. Get your calculator out. Then 814 minus 264. What? Yeah, tell me, what's your question? Do you have a question? Oh, all right. What's the question? Oh. Actually, all that's the same as what we were doing. I don't say that's easy. That's what we were doing. But now we can answer in problem number 2 what x and y were. We can go back and see what in problem number 2. Problem number 2, x is the initial fee and y is the cost per round. Therefore, initial fee, $5.50. Cost per round, 22. Is this accurate? Any golfers out there? Anybody play golf? How much per round if you go play a round of golf? Can you get on the course for 22 bucks? Some, yeah. And then to join the club, $5.50? Depends on the club, but yeah, something like that, yes. So this is fairly accurate. Okay, folks, get ready for the graphing one. In fact, put your pencil down for the graphing one. Because I know the graphing one, something goes wrong here. You're going to have to do it, but you're not going to want to copy it down the first time, let me tell you. It's going to go haywire. Wait till you see. Then we'll decide how to do the last one, whether we'll do graphing, substitution, or elimination on the last one. We can't skip it. We're going to do it somehow. I don't trust you. Problem number 4. C equals, I know it's not written like this. Yours isn't written like this. Mine says 200 plus 10p. Yours doesn't say that, right? And the second one's 280 plus 8p. But that's not the way you have it written on yours, is it? It's the other way around. Because this would mess people up the way we've taught it. We're used to the slope being the first number and the y-intercept being the second number, so we're used to seeing it like this. Now I know what happened. Whoever typed this sheet up said, we better check if they know, not the order of the numbers, but the number has got to be with the letter to be the slope or the rate. Yeah? Well, now you should stop copying for a few minutes till you see what goes wrong here, and then someone's going to need to make a suggestion on how to handle this, okay? Here I go. I see that the start value of the first one is 200. The start value of the second one's 280. I see how many squares I got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I've got to get up to 200 and 280. What could I go up by? Go up by 20s. I like it. So watch me go up by 20s. Don't copy this down. I don't know if it's going to be good or not. And this will be you if you get stuck in this situation. I'm going to go up by 20s. 0, 20, 40, 60, 80, 100, 20, 40, 60, 80, 200, 20, 40, 60, 80, 300, 20, 40, 60, 80, 400. Is that going to be high enough to graph 200 and 280? Yeah, looks pretty good. Now along the bottom, guests. Here come the number of guests. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I hope you're not copying. I told you don't copy this. It's completely wrong. No, it's not wrong. Sorry. It's not wrong. It's my best first move. What's that?
You can't put it on the line.
No, lines is right. Each line represents a guess. So watch. So you see what I mean? I'm going to do the first one. Start at 200 and go up by tens. So 210, 220, 230, 240, 250, 260, 270, 280, 290, 300, 310. Don't copy any of this. It's completely not going to work. It looks good, doesn't it? Other one. 280 and go up by eights. Oh, that's hard. 280 and go up by eights. So that'd be 288, 296, 304, 312. Oh, that's a little too low. 312, 320, 328, 336, 344, 352, 364, 372, 380, 388, 396. Do you see the problem? First of all, are the lines going to intersect each other eventually? Yeah. But they didn't intersect on my page. This is why we hate graphing. That's not going to work at all. What am I going to have to do to fix this problem? Not graph it. Actually, that's a pretty smart solution. A pretty smart solution would be like, let's not go by graphing. What's the problem? When do they meet up? Past 20 people, way out there somewhere. I can't go up by ones here on this graph and expect to ever get to the answer. So this is all wrong. I'm going to need a better scale. Get rid of all that work for nothing. It's annoying. If this happens to you in a graphing question, you're like, oh man, all the way back here, and I'm going to go up by 5 guesses each time. 5 guesses, 10 guesses, 15 guesses, 20, 25, 30, 35, 40, 45, 50. Don't copy it down until it works. Let me do all the work this time so you can see what's got to happen here. Okay, now listen carefully. First one, start at 200. But how much does it go up for 5 guests? It's $10 per guest. I'm adding 5 guests. No. I'm going up 5 guests, and it's $10 per guest. How many? I'm going up by 50s every time. So now this goes up to 250, 300, 350. That's 2.5 squares. 400. It goes right off the page so unbelievably fast. I don't know if this is going to work. The other one, 280. And it's got to go up by 40s every time. So 280, 320, 360. It's not going to meet up. Again, I got to do the same thing with the other scale. Arg. All right, just a second. This one will be right. I got to make this go up by a lot more. I'm going to go up by 40s. That'll solve the problem. So this is 40, 80, 120, 160, 200, 240. Was it 20 I went up by last times? 260, 280, 300. Is that going to be enough? Or 20, 440, 460, 480, 500. No, it's still not going to be enough. Get rid of all that. Erase all that. 100, 200, 300, 400, 500, 600. There. Do that scale. That'll work. And this is what happens with graphing sometimes, is you find out the initial scale you use doesn't work too well. Now I can do it. Now I can handle it. It's all going to go well now. First graph. Start at 200. And for every 5, go up 50. 250, 300, 350, 400, 450, 500, 550, 600, 650, 700. There. That's going to go right down, not the middle of the page, but it covers the page nicely this time. Shh. The other one. Start at 280. And I'm going up, ooh, that's going to be hard. Going up by 40 for every 5. 320, 340. Ooh, I wanted to be in blue. Start at 280. And I'm going up by 40. 320, 340, 360. It's all over the place. Hang on. Just a second. Oh, 380.
Oh, wait, do we copy this down now?
Just give me a second. I'll get it all for you. $280. 5, 320. 10, 360. 15, 400. There we go. 20, 440. 25, 480. 520, 560, 600. There we go. I skipped one when I did it the first time. There's the line. What's that? I did by 5s along the bottom. And then I did by 50s along the side. Eventually getting the answer. Yeah. So, answer. Now you can copy, yes. 40 guests. $600 is where they meet. Busy playing with my microphone here. It's a weird little tab on it. I can't figure out what it's for. So what method would have avoided all this problem? No, not skipping the question. What method would have done this easier because of the big numbers? Substitution would have handled this a lot better, right? So when it's big numbers, you're starting to think substitution. The only reason we did this one like this is because they asked us to do one of them by graphing. So we were stuck with this one with graphing, which is not easy. It's not easy to graph things with big numbers and come out to things accurately. Even I had to stop for a minute there and go, oh, where are we at here? And needed a little help from a table of values to make sure I got all the numbers just right. How's it going? Do you need more time? Still more time? Okay. Because I held you up. I said, don't copy it until I get it right. How have new people buy new shoes? Like how long is good for a pair of shoes? Like 6 months. 6 months? Oh, I don't feel so bad. I just got these in the summer and I really like them. I got them in like July and I'm already looking at them and going, it's starting to look a little beat up. They're good shoes though. Yeah. Do they look like old guy shoes? Yeah. Well, they're so darn comfy. Woo! Yeah. It's like, yeah. Do you still need more time? I'm not trying to rush you.
Yeah.
Yeah, more time? Okay, that's right. Mr. Todd, don't make us do a crazy graphing like that one on the test. I won't. You'll see in the review. All the ones I ask you to do graphing with are nice graphing ones. Yeah, I just was trying to show that it can be done. You could graph one of these, and it works, but geez. No, I'm not done teaching. We're going to choose. This is the big moment of the chapter maybe, where we go, I know which method to use. More time? All right, what's the last one? What was it? 5c plus 3d is 85. And 3c plus d equals 39. Did I copy it down right? I can't even tell. 5c plus 3d equals 85. Got it. 3c plus d equals 39. And that was problem number 3. What are you doing?
I'm trying to count.
Which method? The girls don't want to vote up here. You do want to vote?
Oh, yeah, sorry.
Elimination. Yeah, why not elimination? Elimination would be a great choice here. Because actually, if we've got somebody that's really experienced with elimination, watch how quick this can go. I'm not going to multiply the first equation by anything. It's in pretty good shape. What are you going to multiply the second equation by to make it match up?
What is that set? Set to 3D under the line.
Equals 85. I didn't do anything to that equation. It's still the same equation. What am I multiplying the second one by? Negative. Negative 1's not going to do it. Negative is a good choice. I'm going to multiply 2 by, what's it going to take to match up the D's? Times 3 is really good. Then it'll be 3D and 3D. Negative 3. Yeah, it's good. Negative 9C minus 3D.
What was it, 285?
Wait a minute, what did I do here? You didn't catch me? That wasn't a D.
Saturday, August 10th.
That was a C.
My birthday.
There, that's better. And then 39 times negative 3.
It would have been on my birthday. You want me to die on my 16th birthday?
117. How smart? It's tough to tell anymore how smart I am. Maybe I just remember more than other people. So it's tough to know anymore. Yeah. All right, if you're still having trouble with elimination, just take a look for a second. Why is that so good now? Because it's positive 3 and negative 3. So when I add those cancel. What's that? Well, I don't know, 5 plus negative 9? I don't know if that's... Oh, 85 minus 117. Well, first I subtract 85. And then how much do I have left? I have 32 left. Not bad. Now divide them, yep. Negative 32 divided by negative 4? 8. Now sub that back in. (5c plus 3d equals 85). So it's 5 times 8 plus 3d equals 85. 5 times 8 is 40. Subtract the 40. Divide by the 3. And I'm doing this fast on purpose because I'm trying to convince you that these steps get repetitive. Hopefully you're like, okay, well that part I can do. I'm finding this part over here on the left side hard, but that part, once I sub it in, then that's no problem. And what was this question about, C's and D's? I forget already. What was the C and what was the D? Oh, CDs and DVDs. CDs. Were $8. DVDs were $15. What? Yeah, it is. It is the same thing. You could say that. Point of intersection. 8, 15. Is that the x and that's the y, or is that the y and that's the x? I don't know. So yeah, I get what you're saying. It doesn't fall into the same x, y thing. But if we made c the x because it was first and d the y, maybe that's probably right.
Does it matter?
No, probably not. In a word problem, this is the answer we're looking for is, what are we talking about here? Yeah? CDs and DVDs, yeah. Whew. Oh, what did we solve by? I forgot to fill this in. Elimination.